So we'll go ahead and get started with the first presenter, Dr. James Halbridge. And his paper is titled Measurement of Inheritance Design Quality.
Hello, thank you very much. I'm excited to talk to you today about inheritance design quality, but I really want to make sure that everyone can get something valuable out of this presentation, even if you're not a professional software engineer. So I'm going to tailor my talk about a specific thing. So first, let's talk about metrics. Metrics are relevant in everything we do every day because we use metrics in order to make decisions. And the more we're conscious about the metrics we use, the better our decision-making process can be. And metrics are valuable for no matter what the context is. For an example, in education, I will use metrics to evaluate the quality of the student's work. If I'm designing or building something, I'm going to use metrics to evaluate which of two design options is better. If I'm going to be human resources, I'm going to use metrics to decide who's going to get a raise, who should I hire, or who should I let go in an organization. The more objective we are, the better we are about our decision-making is usually a function of the quality of our metrics. And so my job as a professor of software engineering is to teach my students to make good design decisions. In other words, they have more than one design option available to them. Which one should they choose? And support them, they make that choice in the best way possible. And this is a classic metrics problem here because I got to teach the students the best metrics by which to evaluate their decisions. And so in this particular context, I have to teach my students how to make a decision on what's the best way to design object-oriented programs. And so what I did, my phase one, is I looked at the literature. Now, each one of us should be skeptical about the metrics we use. In other words, we have to make sure that the metrics we're given are the right ones for the job. And when I took a look at the literature, I found a plethora, you might even say a cornucopia of different metrics. And each one of them was a little bit suspect because they described the aspects of an object-oriented design, but didn't really reflect the quality of an object-oriented design. So I have to ask myself, are these metrics the right ones? And so what makes for a good metric? And it turns out there's a large body of research on this. And fortunately, the research agrees that there are three main aspects about metrics, which we should look at. We call these metametrics. Every metric should have, number one, it should have validity. In other words, it should be measuring the right thing. Number two, it should have reliability. There should be a small amount of noise in the measurement. And number three, it should be efficient. Namely, the metric is easy to gather data on this metric. So let's go back a little bit here and talk about validity. Let's say, for an example, I was a high school coach, and I want to try to figure out who I should make run the 100-meter dash. Well, I'm thinking to myself, I saw the person who won last year wore red shoes, so therefore I will pick the person who has red shoes for my 100-meter dash runner. Now, this metric is not valid because the color of your shoes has no difference on how fast you run. It is reliable. I can pick red shoes out very quickly and efficient. It doesn't take me much effort. But if something is not valid, then the metric is no good. Nothing else really matters. So now I'm going to try this again. I'm going to have a bunch of students pick them out of the lunchroom, make them run a 100-meter dash, and the person who runs the fastest, they're going to be my runner, right? Is this valid? Yes, I'm measuring running speed, but is it reliable? The answer is, well, no. It depends upon what shoes they're wearing, what they had for lunch, whether they were sick that day, what clothes they were wearing, a bunch of other different things. There's noise in the measurement, which could prevent me from getting good data. So we need to have stuff that's both valid and reliable. So I'm going to try this again. I'm going to have people run the 100-meter dash. I'm going to have them do it 3 times a day, morning, noon, and night, for 2 weeks. This will allow me to gather statistical data of who the best runner is. Is this valid? Yes, absolutely. I'm measuring running speed. Is it reliable? Well, yes, it is, because I'll be able to weed out anomalous, where someone's feeling particularly good one day, or they wore bad shoes one day, or whatever. But is it efficient? And the answer is no. It's going to take a great deal of cost to obtain that measurement. So we got to find metrics that are valid, reliable, and efficient in that order specifically. So now when I go back and I look at the metrics we had for inheritance design quality, none of them were valid. None of them actually were a reflection of what makes for a good class design. So therefore, we needed to go someplace different. So the next step, I did another literature review, and this is what were the accepted best practices for inheritance design. And from those, maybe we can derive new metrics. And I took a look at the literature from published sources, from textbooks, from talks by influential software engineers through the years, and we came up with a rather large set. And these are each one of these is a reflection of what makes for good class design. Can we organize these into a way that will come up with some valid, reliable, and efficient metrics? And it turns out the answer is yes. And so we can categorize these into three broad categories. First is alignment. Is it aligned to the problem domain? Second, is it adaptable? Is it easy to make modifications to the classes? And third, is it minimized on redundancy? So let's take a look at these three metrics in turn. First of all, is adaptability is the suitability of the class, of the base class, and the inheritance hierarchy to facilitate creation of derived classes which can fulfill previously unknown or unanticipated design concerns. The next one is alignment. The alignment is the degree in which the inheritance hierarchy maps to the problem domain. And the last one is redundancy. It is the extent in which common elements exist in the inheritance tree. We want to minimize redundancy, we want to maximize alignment, and we want to maximize adaptability. So we take the first one, adaptability here, and we want to see if we have face validity. In other words, does this align and predict with the accepted best practices in industry? And these were all the best practices that map to the alignment metric. And so we do have face validity because each one of these metrics does describe what our adaptability is. The second is it reliable? Can we minimize the amount of error that an evaluator will have and determine the adaptability level? And so from the literature, from those best practices, we were able to come up with 5 different levels of adaptability. And we'll get to efficiency in a minute here. And we did the same thing with alignment, where we took our alignment degree in which inheritance tree models relationships in the problem domain, and that corresponds to the best practices that map to alignment. And so we have face validity there as well. And how can we deal with reliability? We're going to take a look at the definitions of alignment from those best practices. We're going to come up with 4 different categories of which will allow us to map a given inheritance design to the quality levels. And we'll do the same thing with redundancy. Redundancy, once again, has a very large number of best practices described in industry. And then from here, we'll get help with our reliability by taking a look at the 4 different levels of alignment from the best practices from industry. Now, so how we have face validity because of each one of our new metrics aligns with the problem domain. We have reliability because each one of the different categories is easy to identify and aligns once again with the literature. The last problem is this going to be efficient? Is it going to take a small amount of effort for someone to be able to evaluate the quality of the design? And this is super important. Because if the student is not able to evaluate the quality of the work quickly and effectively, they will not. If the teacher is not being able to objectively and quickly evaluate the quality of the work, then they will not. But fortunately, we're able to take these 3 different metrics and drop them into a rubric, which facilitates both the student and the instructor be able to determine the quality of their design. All right, so related work, we've done similar work with modularization metrics. We did the same work with encapsulation metrics. There are some areas of future work. First of all, we did face validity, but we need to do a little more work on the validity side by correlating the evaluation of class design quality according to experts' opinions on the same, as well as we could do a reliability testing by doing interrelated reliability by having a number of trained evaluators evaluate the quality of different designs and correlate them to see how they correspond. Questions? Questions? Applause?